Hi everyone, welcome to the twice annual update on Crossplane. Today we're going to go through what Crossplane is for the first half of this talk, and then Jared here is going to dive into some of the more advanced and up-and-coming features in Crossplane. By the way, hi, I'm Nick, I'm a maintainer of Crossplane. This is Jared, he's also a Crossplane maintainer.
Hello.
All right, so what is Crossplane? I like to think of Crossplane as a framework for building control planes, a way to build custom Kubernetes APIs without having to write controllers. So here we've got an example of an app custom resource in Kubernetes. This is not an API that Crossplane has built into it. This is an API that you can create yourself using Crossplane. So why would you want to do this? I think that today, a lot of platform engineering teams, what they're trying to do is enable their developers to self-service. And often, the way that they're enabling developers to self-service is basically building abstractions on top of lower-level concepts, right? So if you're building these abstractions today, you might be reaching for things like Helm charts or Terraform modules as a way to take complex apps and infrastructure concepts like services, deployments, RDS instances, and wrap those up into a simpler abstraction that your developers can work with more easily. Another way that you could do this is by writing a Kubernetes controller, defining a Kubernetes custom resource, building an operator, teaching it how to do that. This gets you a lot of the benefits of control planes that we'll go into later. But that is challenging to do. There's a lot of foot guns. It takes a niche skill set to write a controller for Kubernetes. And so this is what Crossplane helps with. We're trying to make this easier for you to do, try to open it up to more people. So before we go into talking more about what Crossplane is, I just want to celebrate for a minute that we are now a CNCF graduated project. Yeah, thank you so much to our community. It's been about 7 years that the project's been around, right? I
thought you meant how long we're working on it.
And us also.
Felt like that.
Yeah. But we were looking into some of the numbers while we were applying for graduation, and we are now in the top 10% of CNCF projects for number of contributors. We have thousands of contributors from hundreds of organizations, widely adopted at household names in production. So huge thank you to the community. And a special thank you to Jared, who road managed the graduation effort. That is takes a special set of skills and a lot of dedication and time to make sure that the project is ready to graduate and to work with the CNCF. So thanks to Jared for being our liaison. Oh, thanks. All right, so I mentioned that Crossplane is a framework for building control planes. Let me quickly touch on why you might want a control plane. I know that you're all here at KubeCon, so you're probably mostly familiar with this, so I'll go briefly over it. A lot of the benefits that I think you'll hear people point out, which I totally agree with, are the continuous reconciliation, right? You get this closed loop control where Kubernetes or Crossplane or operators look at the observed state of the world, how something actually is, look at your desired state, and are constantly driving the observed state towards the desired state. This is totally a super valuable thing. You also hear people talk about the declarative APIs. 100% agree. It's nice to be able to say, look, here's just how I want it to be, not how to get there. But something that people talk about a little bit less often, that to me I think is a superpower, is this idea of allowing developers to self-service with guardrails. So my background's in platform engineering. I was a platform engineer for 10 or 15 years before I started working on Crossplane. And if I think back to those days before Crossplane, before Kubernetes, there was 2 to 3 ways that you could enable your developers to get stuff done as a platform team. One that I think we've all experienced at some point was ticket ops, right? This is maybe the safest but the slowest way to get things done. Your developers ask you, the platform team, or SRE team, or DevOps team, hi, I'd like a new app deployed, or I'd like a database deployed, or whatever. And when you get around to it, you do that for them, going through the ticket queue, maybe running scripts, maybe using an IAC tool, maybe doing it by hand in the Cloud Console. So that's quite safe, but it's slow. At the other end of the spectrum, there's good luck, have fun, here are the admin credentials to our cloud account. Please don't break anything, but move as fast as you can. This is, maybe not as bad as you would think. For some small companies, it works fine, but it is a kind of a recipe for chaos, and you have to have a lot of trust in your developers that they will make good decisions about what they're going to do. The third option that I think used to exist back in the day was only really available to the most advanced or the most well-funded teams, the teams with the most bandwidth, which was simply roll your own control plane from scratch, right? Build a web portal, build a backend, build an API, build automation that does this, right? Since Kubernetes has come around, with the invention of CRDs and the popularization of the controller and API-driven pattern, this self-service with guardrails has become much more accessible to people, right? Projects like Kubernetes and Crossplane allow you to define an API that is what your platform team wants the developers to interact with. And this API allows them to self-service. They don't have to raise a ticket. They can just provision what they need and manage what they need on demand. But they don't necessarily have access to everything that the AWS console gives them access to, right? Or the Google console, or whatever the underlying system is. Instead, you present concepts in a way that your developers understand. And you may, for example, let's say in our simple app example that we'll go through today, you may say, you can totally choose what image the app is running. You can choose what database engine it's going to use, but you cannot choose whether encryption is turned on, and you cannot choose whether backups are turned on. Those will just always be on, because that's the opinion that we want to make sure all of our apps follow. So that's a quick summary of why control planes. So in August of this year, we released Crossplane v2. It's a pretty big milestone for the project. And we actually released v2.1 last week. We're going to demo only Crossplane v2 style things today. So if you haven't looked at Crossplane v2 yet, you'll get a demo of how it works later on today, or during this session. Crossplane v2 is backward compatible with v1.x. So if you're running Crossplane, I encourage you to upgrade as soon as you reasonably can. The big changes in Crossplane v2 for new v2 style resources, we've made everything namespace by default. I'll touch on what these concepts are if you're not familiar with them later, but XRs and MRs, they now are namespace scoped, no longer cluster scoped. You can now compose anything. We're not opinionated about only composing Crossplane resources. You can compose an app from deployments and services or from other operators in the ecosystem. I'll demo that later. We're less opinionated about how you use Crossplane. We are really seeing it as a framework now. So if you just want to use one layer of Crossplane, if just the composition layer is useful to you, or just the managed resource layer is useful to you, it's totally fine. The system is simpler. We got rid of claims. And something that long-term users of Crossplane will probably be pretty excited about is that we now have what we call activation policies, which means you only have to install the CRDs, the types that you actually want when you install a big provider like AWS. You don't have to have tens or hundreds of extra CRDs that aren't relevant to you installed. All right, so I'm going to start with composition. This is the kind of the user-facing layer in Crossplane. I showed that app manifest on the first slide. That app manifest is what we would call a composite resource in Crossplane, or an XR. It's effectively a special type of Kubernetes custom resource. It's very similar. The main difference is just because it's an XR, Crossplane knows that it owns this. It's the one that's going to be responsible for reconciling it, taking care of it when a user creates one. And as the name implies, the way that XRs work is through a process called composition, which effectively just means it's an abstraction on lower level concepts. In this case, the app is composed of a deployment, a service, and an RDS instance. So when a user self-services by creating an app, Crossplane's going to go and make these underlying things. Again, if you've used IAC tools or Helm, this will all be pretty familiar to you as a pattern, but the big difference with Crossplane is this is all happening in a controller, and you don't have to write that controller yourself. So a quick way to show how this works is to run through a demo. I'm going to find my getting started docs and make them nice and big. Hopefully that's big enough. So we're going to use a slightly simpler version of the app that I showed to run through this demo. This app only has one input. It just has an image that it should run. And for when you create this app, Crossplane is going to make a deployment. It's going to make a service. And it's going to copy their replicas and address into the status of the app. So pretty straightforward. Step one is to make what we call an XRD, a composite resource definition. If you've seen a CRD, this is almost the same thing. The fact that it's an XRD, again, just tells Crossplane that it should be responsible for this particular one. Really, the only thing that's important in here is the OpenAPI v3 schema, which just tells it what a type of resources, so what type of fields it should have. So I'm going to go over to my terminal, which is hopefully big enough. I'm going to create that XRD. And you can see this XRD is now ready. The XRD is ready to go. So now at this point, Kubernetes is serving the app API. If a user makes a request for apps, they'll be registered in the Kubernetes API server. And Crossplane knows it owns apps. Crossplane knows that when someone makes an app, it should do something, but it doesn't know what to do at this point. So to teach it what to do, first we need to pick what language we want to work in. One nice thing about Crossplane, and one belief I have from my years in platform engineering, is there's no one language to rule them all. There's no one configuration pattern. Some people prefer first-class programming languages, Go, Python, etc. Some people prefer templating languages. There's not really a wrong answer. Different ones are useful in different scenarios. We actually support way more options than this, but these are the 4 that our Getting Started guide have. So I'm going to run through and take a show of hands for which type I should use today. So first, show of hands for plain old YAML. Who would like me to use that?
Somebody likes YAML.
That's not an overwhelming amount. Templated YAML, which kind of looks like a Helm chart. Python. KCL, which is a sort of modern Kubernetes programming language. It's pretty evenly tied between Python and KCL. I have practiced the Python demo a lot more, so I'm going to go with Python. And I also cheated here. So this is how you would install support for Python. You would apply this function package. Just because we're on conference Wi-Fi, I have all 4 of these functions installed already. So Crossplane actually has support for all of those languages on my control plane. This is just a kind control plane on my laptop, by the way. So, all right, now we have defined our API. We've told Crossplane that it owns that API. It's responsible for it. And we've also installed support for Python and a few other languages. The last thing we need to do is kind of tie the 2 together. We need to say to Crossplane, when someone makes an app, use Python in this way. We do that in Crossplane with what we call a composition. So I'm going to go to the Python one here. In this simple example, we have some Python that's just inline of YAML. Trust me, I know this is super gross. Don't worry, this is for really simple scenarios where we just have like a couple of lines of Python. You can actually use Python in your IDE or any other language, Go, KCL, etc., build a function. But for the sake of this demo, I'm going to use this nice, quick inline one. Whoops. All right, so now we've created a Python composition. So now we've done everything. We have told Crossplane that you own apps. We've installed Python support. And we've told Crossplane when someone makes an app, use Python in this way with this particular logic. So now, get our app. Apply that. Oops. Huh. Oh, that's good. Must be slightly slower conference Wi-Fi here. And our app is ready and true. I was worried there because it took like 5 seconds when I practiced it earlier, but 23 seconds I think is acceptable. Cool. And that is the entire demo. So if you do kget deploy, you'll see it made the deployment, my app, kget service, made that. And if you get -app -o YAML, you will see that it set the replicas and the status address. And that's it. That's a really simple composition in Crossplane v2. All right, so XRs and composition is one way that Crossplane sort of absolves you from needing to write your own controllers. Another thing it does is it has a massive library of what we call managed resources, hundreds or thousands. And these are effectively ready-made, mostly code-generated actually, controllers that the Crossplane project builds for you. The reason these are useful is because while the Kubernetes ecosystem is extensive, you'll often need to do things that there is no built-in Kubernetes type for, and maybe there's no controller in the ecosystem that does this, especially when we started Crossplane 7 or 8 years ago. So for example, if you want to manage cloud resources like buckets, RDS instances, GKE clusters, GitHub repositories, just anything you can imagine, Crossplane probably has a controller for that. These are what I think of as high-fidelity representations of cloud APIs. So they just take whatever the cloud API is and bring it into Kubernetes and allow Kubernetes to manage that. And they have all the good properties of Kubernetes controllers. They have a declarative spec. They have status that shows you how things are actually working in the cloud, like what the current status is. They constantly reconcile, they correct drift, all that good stuff. In Crossplane v2, these are all namespaced, as I mentioned before. You can compose them into an app or into a high-level XR of any kind if you want, or you can just use them straight up, or you can put them in a Helm chart or build your own custom controller with Kube Builder that uses them. We're not opinionated anymore. If they're useful to you, we want you to use them to build your platform. And the final thing I'll touch on real quick before I pass over to Jared is the package manager. This is the last component of Crossplane, apart from all the new stuff that Jared's going to go through. Package manager in Crossplane is really just a way to extend Crossplane with new stuff. You saw me install some functions before. Those are packages. They pull down support for those languages in Crossplane. I just talked about managed resources. They're packaged up in what we call a provider. So you would install the provider for AWS S3, and that would extend to Crossplane with support for this. We have a package manager because there are thousands and thousands of controllers in Crossplane, and it would be inconvenient to have to install them all by hand. So we packaged them up and made that simple. And the last kind of package we have is a configuration. A configuration can kind of bundle up everything I just demoed today. So it'll take the XRDs, the compositions, the functions, the providers. If you wanted to take everything that we used to just make that app demo and make it a simple thing that you can install by doing kubectl apply -f my web app configuration, that's what you would use there. All right, and with that, I'm going to pass it over to Jared to talk about operations. And we're going to do a quick change of laptop.
All righty, thank you, Nick. I'll just take the HDMI. Sorry, I just dropped your charger on the floor. No disrespect. Okay, now let me make sure I can start mirroring here. Yes, mirror. No, not extend. Choose content. Tiffany taught me how to do this before. Thank you, Tiffany, to help me out before. Mirror. Yeah, sweet. Okay, so I will pick up where Nick left off. Now we're going to talk about operations. So operations are a powerful new alpha level feature that we introduced in V2. So it was not available in V1, and now you can start using it with Crossplane V2. So we think of it as like day two management, operational type of tasks that don't really fit well into that, active reconciliation, composed resource sort of pattern that you're already used to in Crossplane. So basically how it works is that it allows you to run a function pipeline that manipulates really any Kubernetes resource. I said function pipeline. That probably sounds very familiar to you because that's what kind of the underlying power of compositions as well. So there is some user experience overlap there. So the skills you have for writing compositions and function pipelines kind of translate over nicely to operations. It's just that operations run in a different context. So some examples are, doing backups, upgrades, maintenance work, et cetera. It's important to know that operations are like a primitive. They don't really do anything like just on their own. So we're actually pretty excited to see like what people come up with for their environments, their use cases, et cetera. And we really hope that you show that with or share that with us in the Crossplane community to see what everyone's doing with operations. All right, so there's kind of three flavors of operations. Let's see what they look like. So the first one is just a plain old vanilla operation. This kind of runs once to completion, and then it's done. Doesn't really do anything too special beyond that, but it's basically a way to execute a function pipeline of your choosing. This one is invoking a function that does like a rolling upgrade sort of thing. You can kind of tell it what target version to kind of get the control plane updated to, do like the batches of increments that you want to update in a rolling fashion, et cetera. But it just runs once to completion, and then it's done. That's all well and good, but it gets a little more interesting when you can start doing things on a recurring basis or schedules, et cetera. So we have two other flavors of operations. One is a cron operation, which as it says in the name, you could probably guess it, it does things on a recurring schedule. So this one here is an operation that runs basically every 30 minutes. It invokes a function pipeline to basically take a backup of your DB or your group of databases, whatever. It runs on a recurring basis is the key point there. And then the other flavor is a watch operation, which basically allows you to respond to changes and events of really any type of resource in the system. This one's watching for config maps. Anytime a config map changes that also happens to have the validate label on it, this will invoke this function pipeline. Every time there's a change in a config map, that function pipeline will do some validation work, right? So a lot of the special sauce here is in like what your functions do, the specifics and the logic of the functions that you build, or the function pipeline at least. And then these are kind of the means to invoke these operational tasks on a recurring basis in response to changes and all that sort of stuff. So that's what operations look like. I'm going to talk about another feature that was not in 2.0, but it was in 2.1 that we just released last week. And I think it's pretty important because it solves a pain point for sure. All right, so let's talk about circuit breakers, but to do that, before we start that, we need to do a little bit of a reminder on how real-time compositions work. So real-time compositions are an awesome feature in Crossplane. They basically allow you to change something in the system, and for that change to be picked up immediately, the function pipelines, the composition rendering to be invoked, for composed resources to be updated, for like things to just flow through the system really fast. So you don't have to wait for any polling intervals or anything. It's a live system. It updates immediately. It's pretty awesome. The way that Crossplane does that is by basically setting up Kubernetes watches on all the composed resources of a composite resource and the composite resource itself. So it's basically watching all changes, and then it will run a reconciliation in response to that. That's a great thing, except when perhaps a composite resource and a provider don't agree on what the value of a particular composed resource should be. That isn't like a mainline scenario. Obviously, most cases where this happens, it's a bug, but it causes havoc when it does happen. So let's watch how it happens. So basically, this composite resource, it runs its composition, its function pipeline, and it says that for this particular composed resource, it should have a value of 1 somewhere in its spec. That invokes a event because the composed resource was updated. The provider is watching for those events. It goes to reconcile it, say, with an external service like a cloud provider or something, and then it comes back and says, actually, that value should be 2. And then that, in turn, creates an event that the XR is watching, and then it says, no, value should be 1, 2, 1, 2, 1, 2. Oh my God, it just blows up, and it's not a healthy situation. Resource usage goes up because you're in a tight reconciliation loop. You're spinning, you're hitting the API server. Resource up, or usage up, API server down. Not a good situation. How did we fix that? So in Crossplane 2.1, we've introduced this concept called the circuit breaker. You may be familiar with circuit breakers from other things. The SDO has one, I believe. So basically, it's a token bucket. And so it basically watches the reconciliation of composite resources. And if that rate of reconciliation gets too high, goes beyond some thresholds, it'll just shut it down, basically. It'll break the circuit, break glass, stop reconciliation from happening. It does let a few events trickle through while it's in the cooldown period, but basically it stops from hundreds of events per second to much, much, much slower. It cools down for about 5 minutes and then returns to normal, and if the reconciliation rates go too high again, it will break the circuit again. So that's one way to really kind of prevent this hammering of the API server to happen. So let's take a look at it, a live demo, to see it in action. All right. I feel like this is not going to be big enough, so I'm going to, as always, you practice wherever you are, and it's not big enough when you get on stage. All right, so let's just do a look at this XR, this composite resource here. I am going to apply this to the control plane. And basically, all this is going to do is like compose together 3 resources. Nothing fancy, nothing that too interesting. So let's go ahead and use like a Crossplane beta trace tool to look at that composite resource. And we can see, cool, yes, it did. It composed 3 resources together. So our little composite Bork resource composed together 3 little Bork resources underneath. That's all well and good. Let's take a closer look at one of these, though. So let's do a get with a output YAML. And let's take a look at this. Oh, goodness. The generation of this resource is already 498. If you know what metadata generation means, that means that this resource has been updated already like 500 times since I just created it like 30 seconds ago. That's probably not good for the API server. I would imagine, oh, okay, now it's 787 updates we've already done. That's not intentional. We don't mean to do that. We don't want to do that. Let's just get another view on it here real quick. Actually, this one I'm going to copy. I'm not going to type this one out. So we're just basically watching this every second. These are literally the updates we're doing to this one resource. We've done over 1,000 now. We're going to break 1,200 soon. And you can imagine that this is for one resource, right? We have 3 composed resources in this one composite resource. And then imagine if you have thousands of composite resources in your cluster. That's not going to be good. It's not going to be healthy. I don't like this. I don't want to see that anymore. Get away. Let's fix it. Let's fix it. So what we're going to do here, all I'm going to do to fix this is I'm going to install Crossplane 2.1. That's it. The circuit breaker functionality is built into Crossplane, so you don't have to configure it or set it up. You can configure it with the burst rate and the token bucket rate and all that jazz, so you can kind of tune it if you want to, but you don't have to do anything. You install Crossplane 2.1, and what I expect, let me make sure the pods are running the 2.1 pods. Yeah, we got 2.1 running, so that should be good. And let's take a quick look then to watch that composed resource. Much better. We're just holding steady at generation 1600. We are done with all the crazy updates. The circuit breaker has kicked in. We have stopped hammering the API server and bringing down the cluster, basically. Let's get one more little look here at the composite resource, just to see, we've added, to make this discoverable for the user, we've added a condition to the composite resource. It basically says it is not responsive anymore, and because I have broken the circuit, I've opened the circuit here, there were too many watch events. So that's kind of how you can discover it and help kind of realize that Crossplane is helping save your cluster from a provider and a composed resource kind of fighting. So yeah, that's circuit breakers. And then we got one more thing to get into here before we close it out for the day. So let's talk about the future of Crossplane. We shipped V2. We're really proud of it. We graduated the project. We're really proud of that. But we're not done. I'm not done. Nick's not done. We got more work to do. So one of the things that we definitely want to invest in is the package manager. It works on eventual consistency, basically, of you tell it to install a package, then it'll do that. It'll go get all of its dependencies. It'll do those. Hopefully, it's eventually consistent, and that works, but sometimes that doesn't work. So Nick is kind of looking into more of a transaction-based approach, where we can kind of upfront look at all the package, the dependencies that it needs, the current state of the cluster, and make sure that we can do this in kind of more atomic fashion. So bring some reliability to the package manager. The developer experience tooling to make it easier to build things with Crossplane, we really want to keep investing in that. We've got a number of awesome community contributors that have basically built their own tools and donated them to the Crossplane community. So we kind of want to bring those all together into a first-class experience that everybody can benefit from. So if you want to get involved in that, join on our Crossplane Slack, join the SIG CLI channel, and there's opportunities to collaborate and contribute on that. We've talked about V2 basically all day here, and V2 is backwards compatible with V1. You can install it right away. You can start using it to create new V2 style workloads, etc. But your existing V1 workloads that are cluster scoped, it is challenging to migrate those to V2 namespace type of approach. It is a challenge, and so we do need to invest into an experience around that, more guidance for it, some sort of tooling. So do be expecting investment in that area. And then lastly, we've built a bunch of really, really good features in Crossplane, and we want to keep maturing those to be generally available, production ready, reliable for all of you to be using and relying on. So I think that brings us to the end here. We have 2 minutes for questions. And there's a microphone right in the middle there. If anybody has a question and wants to go up there, or you can yell it out and we'll repeat it for you as well. Yes, do you want to hop over there? Do you want to? Yeah, you're close enough, I think. It'll work.
Hello.
Hey.
So sort of a silly question, but for the namespaced resources in the V2 providers, I saw that the API group has .m. What does that stand for?
Managed. We needed a different API group, and we didn't want to put V2 in the API group because that would be weird to have a version of the API group and then have a version of that. So we were like, it can't be that, you can't have one custom resource that is namespaced at one version and cluster scoped in another. It had to move into a different API group. And we were like, we might be stuck with this until the end of time. So how do we just put kind of a nothing burger difference in there? And so we put M for managed resources.
Okay. And then one other question I had was around the way that you would turn off CRDs or how they aren't installed with the management policies.
Yeah. The super short version is there is 2 new types in Crossplane v2. One's called a managed resource definition. It's an abstraction on CRDs for managed resources. So when you install a provider, it won't directly install CRDs, it'll install managed resource definitions. And then to complement that, there's what's called a managed resource activation policy, which basically just matches managed resources by API group. So you just, before you install the provider, you create a policy that says turn on these groups, don't turn on those groups, and it will only turn on the ones that you asked for. It is a pretty new feature. We want to do some improvements. For example, one big gotcha at the moment is you must create that policy before you install the provider. If you install the provider, you can't turn stuff off once they're there. We hope to improve that, but that's the state today.
Alrighty, one last question, then we'll wrap it up.
Yeah, I have a question on the manage operation. So does Crossplane emit any metrics on once the circuit breaker or any other thing kicks in? And how do we roll out the manage operation along with the application? Is something that has to be rolled in separately just for the operation's sake, or should it be part of the application?
For the metrics question, there are Prometheus metrics for the circuit breaker. I'm pretty sure they made it into 2.0. They're definitely in 2.1, but we'll tell you how often the circuit is opening and how often events are coming through and things like that. And I think your second question was how to adopt the operations feature. Was that it?
Yeah.
How to roll it out? I will say it's an alpha feature, and we recommend not rolling out alpha features in production. If it breaks, you shouldn't use an alpha feature in production is basically the answer there. If you want to try it out, though, there is I believe the feature flag is enable operations. So if you pass that, that'll turn the feature on. And then I don't really know how to give you sort of super concrete advice. I would say the documentation is a good place to get started there. At the moment, as Jared alluded to, the reason these operations exist is because people kept saying to us, we have these day 2 things we want to do that aren't a good fit for XRs. But we haven't built many functions yet for operations, and part of that is because we suspect that they're going to be quite specific to like your organization's needs. I don't know how many general repurposable operations there will be. So step 1 is probably going to be figuring out what use cases you have for it and writing a function that sort of implements that logic to do a backup or do a scale up, scale down, whatever it is you want to do.
Got it. Okay, thank you.
Thanks.
Yep. And if you do build one, we'd love to see it too.
Yeah, please.
Please share it with
Come up
us.
with an idea, share it.
All right, that's all the time we have. Thank you so much, everybody. Appreciate it.
Thank you.